Our first reaction, guys, is a synthesis reaction. It's one of the easiest to identify because it's the only one that forms one new substance. Okay, of all the 5 types, this will be the only one that has one new substance. What that means, it only has one product. Every other type of reaction we look at will have multiple products. Synthesis is the only one that has one product, meaning one substance on the right-hand side of the arrow. Now we can abbreviate all of these guys. We will abbreviate them. Synthesis is just an S, capital S, not to be confused with a solid state of matter. All right. So 2 or more simpler substances become one new substance. So the generic equation, guys, is A plus X yields AX. So before, they're single by themselves, then they combine together and bond to one another to form your final product. So it's like saying element 1 plus element 2 yields compound 1. All right, it's kind of the idea or the gist. Now, if you look on your reference packet page, underneath synthesis, that's showing you a binary compound that forms. There's 2 other types of reactions listed there, and we'll get into this more tomorrow. We take more notes on this to really drive home and explain what that information is showing you, because you have it on every test from here on out the rest of the year. But there's other ones as well. So the example, the demo, well, I didn't do the demo for you guys, but we will do a demo at some point. A common reaction is where we take magnesium and we add it to oxygen, and then it forms magnesium oxide. Go ahead and balance this equation right now. So when we balance this equation, Brandon, you want to go for it?
2 magnesium plus 2 oxygen. Well, this is oxygen equals 2 Mg.
212 is what you would have for your coefficients. Absolutely, 212. So guys, this is, again, just an example of 2 elements forming a binary compound. Binary means what? 2. So 2 elements are in the compound. But again, the key is right here. There's only one new product that is formed. That is unique with only synthesis reactions. Everything else will have more than one product. All right? We'll move on to the next one. The next type is the opposite of synthesis. Synthesis means building up. The opposite would be decomposition, which is like tearing down or breaking down. Excuse me. So decomposition, we can abbreviate that with a capital D. It's where you have a single substance. So you have one reactant is all you have. And it produces 2 or more, and the key here is simpler substances. All right, they're simpler substances than what you started with. Opinion, again, this is just my opinion. You guys may find something that's easier for you. In my opinion, guys, decomposition is the easiest to classify because it is the only one. It is the only type of reaction that has one reactant. Everything else will have more than one reactant. And a lot of times, where we're going within this unit, you're going to be given reactants. That's it. You have to identify the type of reaction from those reactants, predict the products, and then balance the equation. All right, that's what we're going to get to by Friday. By the end of the day on Friday, we will be predicting products. Decomposition, guys, you're only given one reactant. Everything else will be given more than one. All right, so decomposition, for me, tends to be the easiest. Now, I will show you guys this demo later on. Maybe I can show you some demos on Wednesday, as well as whatever else we're doing in class on Wednesday. But we can take hydrogen peroxide, and we can break it down into water and oxygen. Go ahead and balance that equation right now as well. But what we can see, guys, we have only one reactant, hydrogen peroxide. It's breaking down into simpler substances, water and oxygen gas. Now, do I have to write the 1 in there? No, if it's assumed to be 1, if nothing is written there. So, guys, that's decomposition. Yes, there's many types. Jake? Yeah. So, guys, there's another specific type of decomposition reaction. Electrolysis, this was the symbol we saw yesterday that had the arrow, and then it had the electron symbol right there, right below the arrow. Again, something you need to be aware of, all of those symbols for your quiz on Friday. You may just well see those on your quiz in some fashion. But what we're doing, we're taking water and we're breaking it down. Now, electrolysis is where you have a charge that's used to break up a single substance. So again, it's breaking it up and forming a simpler substance from your more complex one. So instead of water as a molecule, we have broken it up into its components of hydrogen gas and oxygen gas. Yep. Yeah, it's a specific example of a decomposition reaction. Yep. I wish our apparatus wasn't broken in the back, but we actually have it. It's just our electrodes are broken. But with electrolysis of water, guys, it's really cool because you have two tubes. In one tube, you have hydrogen gas forming. In the other one, you have oxygen gas. And what you can actually see is you can measure the volume of hydrogen gas produced and the amount of oxygen gas. Well, it just so happens that you have twice as much hydrogen as you do oxygen. Why do you think that might be? Because the formula is H2O. So it's something visual. You can actually see twice as much hydrogen from the oxygen when you break water apart into its individual components. Caroline. Synthesis and decomposition, they're opposites. All right, one forms one product, the other one takes one reactant and breaks it down. So they're kind of flip-flop. They might be the easiest to identify because they each have either one product or one reactant. All right, you got to find some way that works for you to remember all of these. The next type is called a single replacement reaction or displacement. You will hear both of those terms. They mean the same thing. Single replacement, we can abbreviate it as SR. Single displacement, SD. They mean the same thing, guys. You have one element, and it's replacing a similar element in a compound. What do you think I mean by similar? What do you mean it's changed a little bit? It's a different element, right? Right, but so think about it, guys. When I say similar elements, you have one element that's going to replace a similar one. What types of elements do we have? Very most basic types. Blank or blank. Metal and non-metal, guys. Metals will replace metals. Non-metals replace non-metals. Now you might be thinking, well, how do we know if they're going to replace one another? We have this thing called the activity series. We will talk about the activity series either tomorrow or Friday. Right now, again, I just want to go through the types of reactions, and then we will, as we do practice, we will get there with it. So what we have, guys, we can see I have A, which is just element 1, and then I have compound 1 here, and then I get compound 2 when they've switched, and element 2. So A is coming in and kicking out B. So that B is by itself, and now A has bonded to letter X. Whatever elements they are. Again, these are not actual elements. These are just generic pieces just used to show you what's generally happening. So an example of a reaction, we can take zinc, we can react it with hydrochloric acid, and it will produce zinc chloride plus hydrogen. Who can tell me how to balance this equation? Anybody? Only one number you have to put in. 2. Where's it going? In front of HCl. All right, it should be balanced right there. So that is a type of single replacement reaction. Again, you'll notice, guys, on your reference packets, below the generic equation, there's like A through C, A through whatever, A through D. There's different types, and as we go throughout the year, we will talk about those more specifically. Right now, we're talking about the general idea, the very basic concepts of these. We will get into specifics later on. Now, this last piece that seems really random, this is going to be something that's going to help you out. Maybe you guys are doing your homework last night, or did the odds, because I know the odds on that page have an example or two like this. where you have something that you have water. So for example, I've got Na plus water yields NaOH plus hydrogen gas. So sodium has gone in and kicked out hydrogen and bonded with hydroxide to form sodium hydroxide and hydrogen. Now, what do you guys notice that's on the right-hand portion of our reaction, but not on the left-hand? H is in two places. Okay, that's one thing. But hydroxide, what do we know about hydroxide? It's a polyatomic, guys, so it should have parentheses around it. Do you see the same polyatomic on the left, though? No. And what I said was, yesterday, we want to, if possible, balance polyatomics as a package deal. If we see them the same on both sides. Guys, hydroxide, a lot of times, you won't see it normally on both sides because of the way it's written. Hydroxide is, however, over here on the left-hand side because of water. I'm going to rewrite the water formula to show hydroxide. If I rewrite it like this, have I changed up my formula for water? No, it's still two H's and one O, so it's still the same thing. But guys, by writing it out as HOH, it makes it a whole lot easier to balance your equation when we treat it like a polyatomic ion that it is. So we can say Na, we can say H, and we can say OH. On the left, well, excuse me, wrong thing. Over here, we've got Na, we've got H, and we have OH as well. Balance it out. We got one sodium on the left. I've got one hydrogen because I'm only taking into account, guys, this single hydrogen because I'm keeping OH together as a package deal. So I've got one hydrogen, I've got one OH. Over on the right, one sodium. I've got two hydrogens because of that piece, and I've got one OH. All I have to balance now, guys, are my hydrogens. How am I going to balance that out? We're a 2 in front, so I'll put that there. That changes my hydrogens. What else did that change? My OH. I now have 2 on the left, so I've got to balance it out on the right. 2 there. That makes this, but I've also changed my sodiums. So that's how we would balance it out. If you see water, guys, in a reaction, single replacements are a good example of that, which is why I threw that hint in here. If you see water, guys, write it as HOH. Now, do you have to? No. But it may make balancing it a little bit more challenging and take a little bit more time because you don't see that OH. Okay, so sometimes when you see water, write it as HOH. It can make your balancing a whole lot easier. If you see hydroxide on the other side, again, knowing your polyatomic ions, why I had you memorize those back in Unit 5. So single replacement. We also have a double replacement reaction. So this is abbreviated as DR or DD for displacement. Use square dance, guys. In square dancing, you switch partners, and that's exactly what we're doing here. So it's a long, roundabout way of saying you switch partners. Okay? So I want you guys to write in your notes, next to double replacement reaction, 1, switch partners, but think of square dancing. You don't know what square dancing is? Go YouTube it. Maybe you can go to like the Legion or the VFW on a Saturday night, and you might see them square dancing. I'm not sure if they do that. All right? It's a tradition long forgotten. Maybe for a good reason. Anyway. Like, try to teach you guys, which I don't know how well that works sometimes. So guys, but here we go. You have ions. Now, later on in the year when we do our solutions unit, you guys will be doing a bunch of your own reactions where you will be doing a bunch of double displacement reactions. Typically, guys, you take 2 solutions, and when you mix them together, something happens. Colors change. Solids form. Gases form. All right? Like I said, I'll show you guys some demos next week of this happening. But what we're doing is we're switching partners. So, like I've said in our last unit, or when we did naming, break up your compounds, draw your lines, right? What always comes first? Metals come first because they're what? What type of ion are they? Cations, guys. Really, when I say metals always come first, I'm going to change that to cations always come first. Right? Cations always come first. So guys, when we switch up our partners, it's kind of like that FOIL method in math class. The outsides are going to pair up. The insides are going to go together. So you notice now you have AY and BX. All right, so you had compound 1 over here on the left, compound 2, then they form compound 3 and compound 4. So you have two compounds reacting together, producing two brand new compounds. That's what's unique with double replacement reactions, which is why we say square density, because they switch their partners. The partners meaning the ions. But notice, guys, the letters A came first in both the ones that it had, and B came first in both that it had. Even though it looks, when we write it out, we drew our lines, X came first before B, we need to make sure the ones that I have highlighted always come first, because the cations will always come first in every compound you have. So an example of this would be a reaction like this. If I had potassium nitrate plus lead to iodide, we react those together, we get potassium iodide plus lead to nitrate. Balance that equation. So what we've done here, guys, potassium was originally with nitrate. Now it's with iodine. It switched its partner. Iodine was originally with lead. Lead is now with nitrate. Oftentimes, when we have a double replacement reaction, one of the new compounds will be a PPT, guys. And PPT means precipitate. Okay? Meaning a solid will form. I can't write today. Alright? A precipitate will form. Like I said, later on in the year, in the spring, you guys will be having a lab that you'll be doing, the reaction types lab, where you will be reacting a bunch of different chemicals together, and you'll see what happens. Lots of observations, lots of stuff that you'll be investigating. Those are what? No. It's all solutions. Try to minimize the fire exposure you guys have, because I don't know if I can trust you. Alright guys, the last type, this is the thing like Drew was just saying. Right? Combustion reactions, everybody's favorite. It's when a substance combines with oxygen, it releases a large amount of energy in the form of light and heat. Guys, often though, combustion reactions involve a hydrocarbon. What elements do you think are in a hydrocarbon? Hydrogen and carbon, okay? So, with combustion, we can abbreviate that with a C. Guys, there's always two things that it will form all the time. So, it says in the most basic definition, guys, it's when a substance combines with oxygen. But not all reactions that you have a substance reacting with oxygen, will it actually be a combustion reaction. Alright? So, if we take a look back here at our synthesis example that I showed you, we have magnesium reacting with oxygen. This is not a combustion reaction, though. Alright? Because there's no the two products that every combustion reaction has with it. So, for example, if I take methane, which is CH4, and I react it with oxygen, it'll produce carbon dioxide and water. And that right there, guys, that's how you know it's a combustion reaction. All combustion reactions produce CO2 and water. Classic example of a combustion reaction, guys, light a match. Anything with fire is a combustion reaction. It produces water and carbon dioxide. Where do you think the water is, though, that a fire produces? It's water vapor, guys. It's a gas because of the heat. All right? Go ahead and balance that equation.